The image shows four different configurations: Fig 1, Fig 2, Fig 3, and Fig 4 for earthing signal cables. The question asks which of these alternatives is correct for a cable carrying analog signals. Let's analyze each figure. Figure 1 shows a single-ended connection where the shield is grounded at only one end of the cable. The signal conductors are not directly connected to ground at either end. Fig 2 depicts a double-ended connection where the shield is grounded at both ends of the cable. Again, the signal conductors are not directly connected to ground. Fig 3 illustrates a single-ended connection where the shield is grounded at one end and one of the signal conductors is also grounded at the same end. Fig 4 shows a double-ended connection where the shield is grounded at both ends and one of the signal conductors is also grounded at both ends. Explanation and advice. For analog signals, the primary concern regarding earthing is to minimize ground loops and associated noise pickup. Ground loops. These occur when there are multiple paths to ground, creating a loop that can induce unwanted currents due to electromagnetic interference. These currents can then couple into the signal conductors, degrading the analog signal quality. Single-point grounding. To avoid ground loops, a single-point grounding scheme is generally preferred for analog signals. This means there should be only one path to ground for the shield. Figure 1. Single-ended shield grounding. This configuration helps prevent ground loops, as there is only one connection to ground for the shield. This is often a good choice for analog signals, especially when the distance between the source and receiver is not too large. Figure 2. Double-ended shield grounding. This configuration can create ground loops if the ground potentials at the two ends of the cable are different. This can lead to significant noise in analog signals. Therefore, this is generally not recommended for analog signals unless specific conditions are met, e.g., very short cable runs and equipotential grounding. Figure 3. Single-ended shield and signal grounding. Grounding a signal conductor directly can create a common impedance path with other grounded equipment, potentially introducing noise. While single-ended shield grounding is good, also grounding a signal conductor at the same end might not always be optimal for minimizing noise in all analog signal scenarios. Fig 4. Double-ended shield and signal grounding. This configuration has the highest potential for ground loops and common impedance coupling, making it the least suitable for sensitive analog signals. Therefore, the most appropriate earthing configuration for analog signals among the given options is Figure 1. It minimizes the risk of ground loops by grounding the shield at only one end. Correct answer.